Let us consider two reactions. We are going to nitrate benzene by using a mixture of concentrated nitric acid plus sulfuric acid at a temperature of 50 to 60 degrees centigrade. The compound form is nitrobenzene. When you do the same reaction over nitrobenzene, that is, the starting material is nitrobenzene, and we are nitrating the nitrobenzene further, that is a mixture of concentrated nitric acid and sulfuric acid at the temperature of 50 to 60 degrees centigrade. The product is metadinitrobenzene, NO2, that is, the next NO2 comes at meta position with respect to the initial one. Now, if we nitrate toluene with the same nitrating mixture, we get a mixture of two isomers, orthonitrotoluene and paranitrotoluene. Here CH3, this is ortho position, here NO2 comes, so this one is orthonitrotoluene plus another isomer form which is paranitrotoluene. So what is the reason behind this difference? Let us consider any electrophilic substitution of benzene. Here benzene, and already a substituent, already a group is present which is say Y, and we are doing electrophilic substitution over that compound. So E plus is an electrophile. So what happens if it comes in ortho position, then the pi bond comes to attack this electrophile to form this cation. The positive charge comes over the carbon which is bearing the substituent already present. Now this electrophile comes above the plane, and the hydrogen which was already present goes to below the plane with respect to the plane of the benzene ring. Then some resonating structures we can have, and that is this pi bond shift to this carbon, this bond, to form another resonating structure. The positive charge comes here, this, and that's electrophile present. Another resonating structure can also be formed when this pi bond shifts to this, between these two carbon atoms. So another resonating structure is double bond comes here, and positive charge shifts to this carbon. So these are the resonating structures if the electrophile comes in ortho position with respect to the substituent already present. Okay, now let us see what happens if this electrophile comes in meta positions. Here the compound, this electrophile, meta positions, this position is meta positions, so bond attacks here to form this cation. Since the bond breaks from this carbon, so the positive charge comes on that carbon atom, and electrophile added to this carbon. Next, the resonating structures, we have this bond shifts here to form another resonating structure. Positive charge shifts here, double bond, electrophile and hydrogen. Next, what happens? This bond shifts to over this bond. So another resonating structure. Here positive charge comes. Okay. Now let us see what happens when the electrophile comes in para position. substituent, electrophile, para position means this position. This bond breaks from this carbon, the positive charge comes here, electrophile above the plane, and the hydrogen already present was in below the plane. The next resonating structure, okay, the next resonating structure will be electrophile, hydrogen, double bond, and that substituent. Now let us consider the stability of the resonating structures formed from ortho, meta, or para positions. When the electrophile comes in ortho or meta or para positions. Let's see the resonating structures here in ortho and para positions. If the electrophile comes in ortho or in para position, then there is a resonating structure in both the cases where the positive charge lies on that particular carbon which is bearing the electrophile. Okay, in meta position no such resonating structure is present. Now if Y is an electron donating group, that is, if the substituent present in the benzene ring has plus I inductive effect, then it will push the bond pair electrons towards this carbon which is carrying a positive charge. So that will make some reduced in positive charge on that carbon atom. That is, this factor will stabilize this two particular resonating structures. Okay, if Y has plus I inductive effect, it will push the bond pair electrons to the carbon which is carrying a positive charge, and the positive charge will be reduced, so it will increase the stability of this particular two resonating structure. So here in ortho and para position, if Y is an electron donating group, that is, if Y has plus I inductive effect, then these two particular resonating structure has some stabilizing factors. If in meta position no such stabilizing factor is present, that's why if Y has plus I inductive effect, that means in case of a toluene, CH3 group has plus I inductive effect, we know. So in presence of CH3, the incoming electrophile, that is here NO2 plus, which is formed by the reaction of concentrated nitric acid and sulfuric acid at a temperature of 50 to 60 degrees centigrade, that incoming electrophile comes in ortho and para position, because in meta position no such extra stability is achieved. But in ortho and para positions, two particular resonating structures are formed where it is getting some stability by the plus I inductive effect of the substituent CH3. Okay, so what we know, if the substituent already present in benzene ring has a plus I inductive effect, then in that compound the electrophilic substitution, in case of electrophilic substitution reaction, the incoming electrophile will go to ortho and para position with respect to the already substituent present. Okay, now what happens in case if this CH3, if this compound or if this group which is already present has a minus I inductive effect, like NO2, you know NO2 group has minus I inductive effect, that is bond pair electron pooling effect. Now if it withdraws the bond pair electrons towards itself, making this carbon electron deficient. So where the carbon is carrying a positive charge and Y present has minus I inductive effect, then it will destabilize these particular two resonating structures by withdrawing some electrons, some negative charge from where? From a carbon which is already electron deficient. Okay, so that will make these two particular resonating structures very much unstable. That's why If Y has minus I inductive effect, the incoming electrophile will not have any tendency to follow this or that pathway, will not go to ortho or para position, because if it go in ortho or para position, then two particular resonating structures will be formed which will be very much unstable as the minus I inductive effect of the substituent already present. Now in meta position, no such destabilizing factor is present. That's why if Y has minus I inductive effect, then the incoming electrophile will go to meta position with respect to the substituent already present. Okay, so if NO2, the substituent present in benzene ring, if it has plus I inductive effect, then it will be ortho para orienting, that is, in presence of that substituent, the incoming electrophile will go to ortho and para position. And in case of, if this substituent has minus I inductive effect, then it will be meta orienting or meta directing. It will direct the incoming electrophile towards the meta position.